Okay. Two things I didn't explicitly teach you for this worksheet. First, Newton's third law. Um, because I messed up on the copying of the test, threw off the sequence. So Newton's third law, you're probably exposed to it in middle school, but for every action there's an equal and opposite reaction. We'll unpack that at great detail over after Thanksgiving. Thanks. She is not here.
Sounds good. Thank you.
Thank you. And the second one was vector diagrams. So like taking the diving one, I can't remember what the numbers. The initial momentum was what? For was it number 6? 5.5. And we're going downward. I'm going to make the way it's moving positive. And then afterwards, so this was the initial momentum. And then your final momentum was what? Still going down.
What's your first speed?
Sorry, kind of need the. Sorry, you're number 7. What was the momentum? Okay, so 341 going down. And then your final momentum was 68, also going down. Good with that? And your change in momentum is equal to your final momentum minus your initial momentum. So from a vector point of view, when we subtract, remember how we flip this? Flipping that takes that negative, it's like plus and negative. Like from vector addition stuff a long time ago. You flip it, you subtract, you flip the thing you're subtracting, and then you're doing the resultant of these two. So this, doing head to tail, I'm going to take the tail of this and put it at the head of this. And then the resultant, you go from the origin to your final head, which was that would end up being negative 273 because I made the way it was moving positive, change momentum to the opposite. Right with that. So. Okay. I want to show you. So following through. This is always like, I don't really care what sport you play. They always advise that following through is a good thing. Okay. What that enables is more time to exert the force. Okay. So to demonstrate this, what I'm going to do is I'm going to kick a soccer ball without following through and then with following through. Okay? So to kick it without following through, what that means is the first time I'm in contact with the ball, I'm going to stop kicking. I'm going to stop my foot. In practicalness, the way I'm going to do that is I'm going to kick the floor to stop my foot. Does that make sense? Okay. So when I kick, so you're just going to listen. Okay, that's not following through. Second time, I'm just going to kick normally, following through. I'm not going to kick any harder. I'm just following through and observe the difference. Follow through. Okay? Now, when you look at this, you're like, how is that really that much more time? Well, when you look at slow motion stuff, it's a whole nother world, a whole nother reality of that. So this is slow motion of a tennis ball being hit. So if you look at this, right there is when we first are in contact. So if you didn't follow through, you would stop right here. Notice how flat that tennis ball gets. So from all this is following through, the tennis ball leaves the racket about right there. So from here to here was follow through. Okay with that? Did you guys see how jello-like the tennis ball looked? Look at this. Look at watch this. So cool. You guys see that? See the jello effect? That's so cool. Good? Okay, following through. Okay, next question. First questions of the day. Oh, your neighbor?
No, it's just a calendar with like.
Correct answer is? Good. Crazy cats. Okay, to answer this, you are either going force times time or mass times change in velocity. Which one's the definitive, rock solid case approach to give you C? Kitty.
Mass times change in velocity.
Yep. They both have the same mass. They're both going. They started at 60 miles an hour and they end up with 0. force times time, you're like, I don't know. Good with that? Yeah. So, here is brick wall experience. Okay. Here is haystack. So you know those big barrels in front of the middle column in an interstate, the overpass? They're either filled with water or sand. Okay? And what they're trying to do okay? Notice the difference between the front of the car or truck here versus the front of the truck here. Okay? Okay. Same scenario, different question. Tell your neighbor. There we go there. Okay. Next.
I think the one in the brick wall was good.
Okay. So this one hopefully pretty obvious. Brick wall, yes. Okay. So check this out. If I take time and I bring it over here, mathematically, I get net force is equal to change in momentum over change in time. I can say this, I can explain this conceptually as the rate at which momentum is changing. The faster momentum changes, the more force is required. Okay? This is actually how Newton wrote his second law. It wasn't F equals ma, it was force is equal to the rate of momentum change. You okay with that? And this is why the haystack is this idea. So here we change momentum really fast, small amount of time. The haystack allowed your momentum to change more gradually over a longer period of time. And this is why pads, any type of pad, like athletic pads, work. It changes your momentum over a longer period of time. Good with that? Same scenario. Neighbor?
Oh, yeah. It's so funny. Please don't tell me. No, I wasn't funny, but I was just like talking, but it's funny. She like, you hear my towel? I was gonna like, she like built like with me and Libby. Because Lily wasn't there. We were like all.
Correct answer is? Everybody go with C. Okay. Impulse. Force times time. This is kind of fuzzy. But that's also equal to change of momentum, which we established was the same. Okay with that? Next question. Have a conversation.
Yeah, it's gonna be 80
For the English history test? It's like forced
Okay, what do you say? What would be really helpful to know? Time. You don't have enough information. Cannot be determined. E. Okay? So, you know your change in momentum. It went from fast to zero. Therefore, you'll know your impulse, but in order to figure out your force, you need to know how long it took to change from going from 0.8 to 0. Good with that? Last question. Last question. Thumbs up when you have a guess.
It's your sign, it doesn't show limit.
Okay.
It's quicker than a word.
Talk to your neighbor.
I think it's well, yeah, yes, but how? Maybe like a big I've seen your dad drive over.
Me too.
Stronger. Yeah, I think you never shot it. I guess maybe.
Can you get your lunch? During 16, or are you gonna get them during 4? Like, I think you're gonna end up eating lunch by myself. But I know I still say this. That's okay.
Correct answer is? Correct answer is A. What? A motorcycle speeds up way faster. Yes, it does. Practical experience tells us the acceleration of the motorcycle is way greater, way more than the Mack truck. However, the change in momentum incorporates mass as well. Okay? So, it has twice the amount of force, it's going to have twice the rate of change in momentum. Okay with that? Good.
Could you also just say it's the same amount of time and double the amount of force?
You could. Yep. Good with that? Okay. So, there is that. No homework.